Assalamualaikum. My name is Abdul Rafi and I am here to explain different sensors and their simulations in Proteus uh, with an Arduino Mega board. So let's start with this part. Here we have a current sensor AC712. Uh, we have a voltage source. So the current flows through this. And this is a switch, and the current flows through this to the current sensor. Here we have a VCC which is used to turn on this current sensor. So when the sensor is on, the current through this line reaches this sensor through this IP plus. Now AC712 sensor works on Hall effect principle. The Hall effect principle is that when the current is coming through this path, it creates a magnetic field inside this sensor. There is a plate inside this sensor on which the electrons are present. So when the current enters this, it creates a magnetic field. So the electrons there are shifted to the end of the plates, and at the end of the plates we have detectors that detects the amount of current reaching this circuit. Now the information from this sensor is linked with the Arduino board where it is processed. Now we are moving to the second sensor, that is a voltage sensor. It is basically a potentiometer, nothing else. A potentiometer works on the principle of change in resistance. We apply the voltage here, and the potentiometer we can change its value from we can add or subtract the value from this bar. So when the voltage comes through this, the potentiometer notes the value and uh, send it to the Arduino for further processing. Now moving toward this part, we have a sensor DHT11, which is basically a data logger. Now this data logger tells us the value of temperature and humidity. Uh, it tells us the value from 25 to 90 humidity and 0 to 50 degrees Celsius temperature. Uh, this data logger DHT11 is further connected to the Arduino board, and uh, this this thing is a real-time clock. So whenever the data from data logger is stored, the it creates a timestamp on it. Like if at 4 a.m. the temperature is noted, the real-time clocks send a signal to the Arduino so that a, a timestamp is added to this, and we have a personal record. This thing is a serial monitor which shows the info. Now moving toward the SD card, this is used for storing the information. Like we have collected data from AC71 to a voltage sensor, data logger. This all data is stored in the SD card via the Arduino board. Now moving towards the pin configuration, we have SCL, serial time, sorry, serial clock, or and SDA means serial data. The data, the time and the data are linked with the Arduino board. Now this all is connected with an Arduino board. The Arduino is like a central processing unit. It processes all the data and store it in the SD card. Now the SD card is connected with the CSDI, DO, and CLK pins. Now the CS pin is connected to the meso pin of the Arduino. Meso means master in, slave out. The DI pin is connected to the MOSI, that means master out, slave in. DO is connected to the SCK, that is serial time clock, and CLK is connected to the SS, that means slave select. Now the Arduino sends info to the card at the specific time the data is read. So here we have all this. Now moving towards the Arduino code that this Arduino uses. Now first we have added the libraries here. SPI and SD are the two libraries for the SD card that stores information. DHT library for the DHT11 sensor data logger, and RTC for the real-time clock library. Further moving, we have that current sensor information. The current sensor information is like it has some predefined values. Uh, Constant current pin 7, so we can see that the A7 pin is connected with the current sensor, and ADC value is set to 0, offset 2500, and the starting current value is 0. Now DHT pin 6, like DHT11 pin is connected to the 6 terminal. This all is some pre-selected information. Now moving further, we have created a file with that name my files to store the data. Now this is the main function, and it has its own RTC is the real-time clock, and we are using DS1307 real-time clock. Now real-time clock is real-time clock is used to store the data about the time, date, and year, like that. We have coded it here. Serial begin 9600. It's a standard delay time. Now setup for the RTC. Here we have the loop. If RTC finds something, it shows info. If it didn't, it prints couldn't find RTC if it is not attached. This is the date and time stored in given by the RTC to the Arduino to store in the SD card. If the RTC is not working properly, we get an error on the serial monitor that RTC is not working. That is defined here. Now moving toward the SD card, we have the SD card. At the start, we have initialized the SD card. Uh, if SD card begins, so then there is a message initialization. Now my file is the file that we are using to store the data. So here SD open data text and file write. So the data in the form of text is stored, and the file write it keeps adding on the file as the data logger and all the sensor are giving its value. Now if the file opens, it's like file is open. Okay. Now logging time creates proper info about the time, at which specific time the data is stored. So here is all my file that the data is stored in the SD card through this my file print, and now the serial prints the data on the serial monitor. Here DC represent the decimal values of the file. Now this is logging time. Now we have logging temperature and humidity from the DHT11 sensor. Just like the time, it's same. Uh, like it prints the time, uh, and it prints the temperature and humidity at a certain point. And if and we have created a code that if DHD sensor is not working or not reading due to any kind of error, so it brings a message that failed to read from DHD sensor. Now we got debugging processes purposes. This all humidity, percentage, temperature prints all this serial print. The serial print is used to print the info. Now again the SD card, just like mentioned above, it creates the data and file, right? And if it is stored in the SD card, it will open successfully. Here we have a loop that if sensor value, basically we are assigning pins to the Arduino and link it with the sensors or SD card. Now this thing is for the voltage sensor. We have ADC value, and it is linked with the analog pin of the Arduino. We have ADC voltage minus offset voltage, and we have a predefined sensitivity. So if there is a voltage that is coming from the voltage source minus the offset voltage, we have set it to zero. And zero, yes. So this is the kind of formula for the uh, current value, the value of current at that specific point we are taking. Now we are calling the functions here: logging time, logging temperature, humidity, and these functions are all called. So when the complete uh, code is run, we have to take like another second value. So these all functions are called again, and we can take whatever values we want to take from this all. Now moving towards the simulation, we have created the Arduino file and converted into hex file so that the Arduino can work in the Proteus. Here we have the converted hex file. We open it in the Arduino and run it. Like we have a virtual terminal and it's initializing the SD card first. Yeah, so there's a voltage 5 volt. We have set it that point, and it's in the millivolts. The current at this point is 13.47 milliamps, and this very thing is the info about the time and the date. And now the DHT sensor is giving value of 80 and 27 as seen here. Now it keeps running and running and stores it in the SD card until we have turned it off. So that's all with my presentation. I hope you like it, and thanks.